So today I wanted to talk about multinomial data. Multinomial experiments consist of n identical trials with k possible outcomes and independent trials. The best way to explain this is with a problem. Here we're going to look at a multinomial experiment with k equals 3 cells and 320n that produced this data in this table. Now what we want to find is if there is sufficient evidence to contradict the null hypothesis HO equals HO with P1 equals 0.25, P2 equals 0.25, and P3 equals 0.5, while we assume an alpha or a type 1 error rate of 0.05. So the first thing we do is we write down the information from that. We put k equals 3, n equals 320, we put our null hypothesis and the alternative, and also our alpha, which is 0.05. This is our t-statistic formula that will also turn out to be useful for us. And this is the value of E, what E is. The O stands for observed, which is what we see on the table here. The O is the observed, which we see on the table here. And the E is the expected, which we calculate here with 320 times P, which will be each of these P's. So here we made a table, cells 1, 2, 3, they're observed, and now we will find their expected. So I already calculated this, and I found that 320 times the first P, which is 0.25, equals 80. Now 320 times the second P, which is 0.25, is also equal to 80 because it's the same thing, and 320 times 0.5 is equal to 160. Now when we apply this t-statistic formula, which is what we have here, we will get the first one is 0.05, we will get the second to be 5, and we will get the third to be 3.025. Now, we sum all the t-stats, and we get 8.075. Because of the large z, or the large degrees of freedom, our n is 320 minus 2. It's irrelevant because the table only goes to 25, so anything larger than that with 0.05 would have to be 1.645. No, yeah, 1.645. And what we get is we get an 8.075. So basically our thing falls within the rejection region, which is here in the graph. And so what we do is we reject HO.